All right, so like I said, title is Coordinate Reflections. And the last 2 days we've been talking about transformations. So what are the two types of transformations? Yeah, Taylor? Translation and reflection. Good. And a translation is when you take a figure and you slide it. And a reflection is when you take a figure and reflect it across a line. Now, what happens in a translation is everything goes in the same direction and it goes the same distance. But what happens in reflection is still goes the same direction, but it might go a different distance. Because if you're close to the line, then you reflect close to the line. But if you're far from the line, then you reflect far from the line. Okay, so translations are same direction, same distance. Reflections are same direction, but maybe different distance. So that's kind of a summary of the last 2 days. Okay, so now today we're going to talk about coordinates, and we're going to start with number 1. But above number 1, I need you to put letter B. Okay, so we'll start with number 1. Let's see, I think you'll be good there. I'll get it for you in just a second. Okay, so B you're going to go back and do later. This is number 1, and you need a y-axis and an x-axis. And on your graph paper, just use the upper left-hand part. So like y-axis here, x-axis here. So just use this space right here. Y-axis and then x-axis for number 1. And the points we're going to graph are M, W, D, and A. And they are -1, 5, -1, 4, 1, 5, and 4, 3. So just graph those 4 points. All right, so let's see, -1, 5. Is M. -1, 4 is W. 1, 5 is D. And 4, 3 is A. And then I want you to connect those. And you get a 4-sided figure. But it's a weird looking 4-sided figure. So it's not anything special like a square or a rectangle or anything. It's just called a quadrilateral, quad for 4. Okay. Well, I don't think any of the sides are parallel. So yeah, there is a weird shape called a parallelogram, but that's got some special qualifications. And yeah, this is not parallel to that, so that's not a parallelogram. Good. Okay, so what we're going to do is we're going to reflect across the x-axis. So that means we're going to take this figure. Here's the x-axis, right? We're going to take this figure and reflect it down to here, across the x-axis. Okay, so when you reflect, the distances need to be, the line of reflection is in the middle, right? So since this W is 4 away from the x-axis, that means the W prime needs to be down here 4 away from the x-axis. Because the line of reflection is supposed to be in the middle. Do you remember yesterday we did midpoints for the line of reflection? So since that's 4 away, this needs to be 4 away. So counting 1, 2, 3, 4. So counting 1, 2, 3, 4. So that's W prime down there, the new W. X-axis has to be in the middle, so 4, 4. So then for A is 3 away from the x-axis, so then it needs to come down here 3 away from the x-axis. So there's the A prime. And then the D is 5 away from the x-axis, so it'll end up being 5 away down there. So 5 and 5. The line of reflection, which this time is the x-axis, is the middle, so that's 5 and 5. Okay, and then M is 5 away, so the new M will also be 5 away. Okay, so then you connect that. So then you can see, mine's not perfectly spaced, but on yours it should be. Then you can see that that got reflected down to there. So we reflected across the x-axis. Okay, so now we're going to write down the points that we got. So W prime is -1, -4. And then D prime so let's count that. It's to the right 1 and down 5. So it's 1, -5. And then A prime is to the right 4 and down 3. So it's 4, -3. And then M prime is right here. It's -1, -5. So there's all the primes, all the image points. Okay, so eventually we would like to not have to graph, because graphing is kind of a pain. So let's look at the pattern here. What's happening from the M to the M prime, the W to the W prime, the D to the D prime, et cetera, et cetera? Yeah, Charlie?
All the Y's were negative.
All the Y's used to be positive, and now they're negative, right? Which makes sense, because these points were above the x-axis, and then they got reflected below the x-axis. And if we did it the other way, like if the original points were down here, the Y's would be negative, and then they would end up positive if we flipped them up to here. Okay, so when you do an x-axis reflection, the Y's are going to be the opposite of what they were. So in this case, it was 3, so then it became -3. It could be the other way around. Like this could have been a -3, and then it would become a +3. So that's going to bother people because it's an x-axis reflection. but the y changes. So watch out for that. We're reflecting across the x-axis, but the y changed. Okay, so now we're going to skip to number 3. And I'm going to plot number 3 on this one so I'm a little more exact with my plotting, see how this goes. So let's see, we need some points. H is -2, 3. L is 0, 2. Q is -2, 1. And P is -3, -2. So plot those 4. -2, 3. That's H. 0, 2 is L. -2, -1 is Q. And then -3, -2 is P. And that one connects as well, but kind of weird like this. I wanted to do it this way. I want you to connect H to P and then L to P. No, sorry. L to P, P to there, and H to there.
Q is supposed to be -2 and 1.
I could have, yeah, that's wrong. No problem. Let me fix this. Thank you for being patient with me. I really appreciate it. I'm trying to use this newfangled thing here that's messing me up. All right, so we got -2, 3. That's H. And 0, 2. That's L. And then -2, 1. That's Q. Am I good now, Charlie?
Yeah.
Thank you. -3, -2 is P. Okay, then I want to connect H to Q, Q to P, H to L, and L to P. Okay, that's looking better. Thank you. Everybody having fun? I thought so. Okay, now this time, what we're going to do is we're going to reflect across the line y equals x. And the line y equals x has all the points where y equals x on it. So for example, 1, 1 is on y equals x, and 2, 2 is on y equals x, and 3, 3 is on y equals x. So here's 3, 3, 4, 4. So we're going to have a diagonal dotted line, and that's the one we're going to reflect across. So last time we reflected across the x-axis. This time we're reflecting across this diagonal line. And that diagonal line is called y equals x, because for all the points on it, the y equals the x. Okay, so we have to count to see where we go. So here's L, and it's 1 away from the reflection line. So we need to go 1 away this way to get L prime. It's weird because I'm counting diagonally. So it's 1 here, so then I need to go 1 this way. because the reflection line's supposed to be in the middle, right? So since this is 1, this would be 1 as well. So the new L is 0, 2. This is tricky to see. Is everybody okay? Yeah, 0, 2, 2, 0, yes. It's tricky to see where the point ends up. Is everybody okay with counting diagonally? The key is that the reflection line's in the middle. So that has to equal that. Okay, so the new L is 2, 0. Okay, now let's try Q. Q is a little bit trickier because it's 1.5 away. 1 diagonal and then half a diagonal. So I have to go half and 1 to the other side. So Q was here. It's 1.5 to the dotted line. And so then I go a half and 1 to get to the new Q. And then P is just a half diagonal away. So I have to go a half diagonal away to get to P prime. See how P is really close to the reflection line, so it's going to end up really close to the reflection line on the other side. And then I've got H left. So let's see, H is 1, 2.5 away. So I got to go a half, 1, 2 away. Okay, so that's going to end up looking like this. So what happened was I took this figure and reflected it over to here. Okay, so that's kind of tricky. Is everybody doing okay? Remember, I'm impressed if you're willing to admit I could come and count for you at your desk. I know you'll feel silly if you do that, but it could make a big difference. Because I mean, don't feel bad having trouble. I even had trouble graphing the points, right? Okay, so now let's write down the points. So L prime was 2, 0, because it was 2 over. Q prime is over 1, down 2. So it's 1, negative 2. P prime is back 2, down 3. And then H prime is over 3, down 2. Okay, so again, we'd like to avoid graphing in the future because it's a pain. It's easy to make mistakes. So what's going on here? Yes, Judah? The X's and the Y's are getting switched, right? So negative 2, 3 became 3, negative 2. 0, 2 became 2, 0, et cetera, et cetera. Okay, so now we know if we remember that, then we won't have to graph. We'll just be able to switch anytime. That's when we're reflecting across the line y equals x. Okay, so we're going to put that stuff down on a note card. And it'll be good if you can remember it, but also you'll have this as reference as well.
next to
Yeah.
pick up a spider.
Spider.
Yeah, I just killed a
Terrible.
spider.
Thank you for rescuing us from it. Thank you, sir.
Thank you.
Okay, so this is note card 15. Note card 15, and the title is Coordinates for Reflections. And the first kind of reflection we did was a reflection across the x-axis. That was number one. And so I just erased it, but what happened was the point x comma y. So when you do an x-axis reflection, this always bothers people, the y switches. So don't change this one. For an x-axis reflection, this stays the same. So the x stays the same. What happens to the y is it gets opposited. So we'll write down opposite y. And that is an opposite sign. Don't start thinking that the answer has to be negative. If the original was negative, the answer would be positive. If the original was positive, the answer would be negative. This means take the opposite of whatever it was. Okay, then we did a reflection across the line y equals x. And what happened there was the x's and the y's switched. So that's still up here, so you can see the evidence. Negative 2, 3 became 3, negative 2. So this will be xy will become yx. Okay, then sometimes we'll also reflect across the y-axis. So that would be when we take this over to here, across the y-axis. And we didn't experiment with that, but what happens is, and this always bothers people, when it's a y-axis reflection, the x changes. So it's going to be the opposite of x, and then y. And then the final type of reflection we're going to do for coordinates is across the line y equals negative x. And just so you know, y equals negative x, that's this. A diagonal line going this way. Y equals x is a diagonal line going that way. Y equals negative x is a diagonal line going that way. And what happens there is the x and the y, they switch, and they opposite. So xy becomes opposite y, opposite x. Okay. So let me pass out the hole punch so you can keep yourself organized.